Hello, my name is Sam and this presentation is on the square of opposition. Before we begin, you need to understand one key part of formal logic, and that is the proposition. Now, propositions are the fundamental building blocks of logic, and we use them in nearly every aspect of formal logic. Now, propositions are built out of four components, which are the subject, the predicate, the copula, and the quantifier. We'll look at all four of these components as it is essential to understand propositions, which are the main component in the square of opposition. Here's an example proposition. All ice cubes are cold objects. Now, let's split this proposition into its four parts. Ice cubes is the subject. A proposition connects the subject with the predicate, which is cold objects. Now, unlike in grammar, in formal logic, predicates are not verbs, they are always nouns. Note that this predicate adds information to the subject. We took ice cubes and added the information that they are cold objects. Now, the subject and the predicate are connected by the copula, which is just a fancy name for a verb of being, which is usually is or are. As in our example, the copula is are. Now we are on to the quantifier, which symbolizes how much of the subject we are talking about. In our example, we are talking about all the ice cubes. Okay, now that we have the structure of the proposition, it is almost about time to move on to the square of opposition. But before we go on, I just want to point out that propositions must make a statement of fact. They cannot be questions, commands, exclamations, greetings, nonsense sentences, which are sentences that do not give reasonable information, or self-reports, which are beliefs. The final thing I want to talk about in relation to propositions is the quantity and quality. The quantity refers to how much of the subject we are talking about, and can be found using the quantifier. The two quantities are universal and particular. The quality refers to whether the proposition affirms or negates an idea, and it is also found by the quantifier, or the word not, as we shall soon see. The two qualities are positive and negative. Now, the quantity and quality determine what the type is of any given proposition, and there are four different types: A, E, I, and O propositions. I will give you an example for each type, and they will be structured in the form of all S is P, S standing for subject and P standing for predicate. A, all S is P. E, no S is P. I, some S is P. O, some S is not P. These four types of propositions will become very important as we move on to the square of opposition and the relationships of equivalence. Speaking of which, it is finally time to examine the square of opposition. First off, what is the square of opposition? Well, the biggest benefit of the square is that you can see how different propositions stack up against variations of themselves, such as if you believe that all stones are rock, you can compare other variations such as some stones are rock, no stones are rock, and some stones are not rock. You can see whether or not these propositions are true or not. Since the square of opposition has quite a few relationships, let us start simple with an empty square. Now, the first thing we want to add is the four types of propositions: A, E, I, and O. We will add all these and their S is P examples. Now that is done, we want to look at our first relationship, contradiction. Contradiction is the iconic diagonal lines between A and O and E and I. The rule here is quite simple. If one is true, the other is false, and if one is false, the other is true. Both the relationships between A and O and E and I go both ways. Here's a quick example. If all rubber is bouncy is true, then some rubber is not bouncy is quite obviously false. Similarly, if no rocks are bouncy is true, then some rocks are bouncy is false. Next on the list is contrariety. Contrariety compares A and E propositions. The rules of contrariety are as follow. Both cannot be true. You can't have all ice cream is yummy and then have no ice cream is yummy, but both can be false, such as in the case some ice cream is yummy is true, and some ice cream is not yummy is also true. Both the A and E propositions are false. Similarly to contradiction, if one is true, the other is false. But unlike contradiction, if one is false, the other is undetermined. such as in the case that all rocks are hot is false, because some rocks are hot could be either true or false, so you don't know if no rocks are hot is true or false either. The next one is subcontrarity, which is extremely similar to contrariety and is pretty much contrarity's opposite in some aspects. Subcontrarity compares I and O propositions. Both can be true, as if you have some pie is cherry pie and some pie is not cherry pie. However, both can't be false. You have to have at least some is or some is not when you are referring to anything. If one is true, the other is undetermined. For example, if you say some gum is hard gum, there may or may not be some gum that is not hard gum. All the gum may be hard gum. And finally, if one is false, the other must be true. Like I said earlier, you have to have at least some is or some is not, or you have nothing. Alright, for the final two, we have some simple ones. Starting off with superimplication. This compares the relationships of all four propositions going from I to A and from O to E. Superimplication only has one rule. If I is false, then A is false, and if O is false, then E is false. This goes up the square of opposition. Now for the last one, subimplication. Like superimplication, these involve all four propositions, but it is reversed, going from A to I and from E to O. There are two rules. If A is true, I is also true. And if E is true, O is true as well. The second rule is that the falseness of the universal propositions A and E doesn't mean that their corresponding propositions are false, such as all flowers are red. If that is false, you can still have some flowers are red is true. In conclusion, I want to say that the square of opposition is quite complex, yet quite simple when you understand it. Using it, you can infer new statements from other ones based on these rules. This allows you to see what can also be said about what you know is true. That is it for this presentation. Farewell.